Okay, so as we have already discussed what scalability is all about, I thought it would be awesome to actually create a basic video tutorial to explain my concept better. Having said that, the most important thing about scalability that I would really bring into the attention all over again is really the time saving process which scalability provides in general to the RDBMS systems, or if you talk about the distributed computing systems, it really sort of helps decreasing the overall time for which a particular system is going to produce a specific set of output. And I think the really best thing about scalability recently has been by scaling out or probably putting more node or clusters to systems, and then actually all of those systems really focusing and executing on one specific task. So yeah, that was pretty much part of the scalability, and I'll probably sorry about that. I'll probably move forward on my discussion about it. And yeah, so continuing forward for scalability, let's sort of do a pattern matching algo. So let's say if we divide the sections into different components, let's say we have, you know, this. Just please forgive me for my drawing. It's not been good lately, and I haven't been practicing much on the board. So yeah, okay. So let's just take a situation where we have all these elements. Just please do not confuse this with an array or indexing. It's just that my drawings are not really very good, and I was supposed to show the set of strings together. So I sort of find it really cool if I was supposed to show the strings like this. So let's take a situation where we have the string at the bottom as A, B, B, and C, alright, okay. Let's assume the situation that we're supposed to actually look up for the string while iterating through the structure that has been given to us, alright, like probably from here. The first thing that we can do is actually compare whether the element in this, does it equals the element here. So let's say if the element on this vertical line says, let's say it just says A, B, and C. So now we know that the string that we are actually looking for is not the string that's on the first index. So we sort of, yeah, this is not the one. And we move to the next string and then compare this, given that none of these strings are actually the one that we're looking for. So we keep moving until we actually reach in at this point where our strings match. Alright, so yeah, correct. So the most important thing here is, let's say if we had n equals 60 elements, alright, so for such an operation to actually happen, we'll need how many iterations? 60 iterations, right? Because it's quite possible that the element that we're looking for is actually at the end for that. So if there are n elements, we're supposed to actually perform n number of iterations, right? So the complexity of the whole operation becomes order of n. And yeah, so this is like kind of, so from a scalability perspective, if we want to really throw light on the concept of scalability over the problem statement we're trying to solve, is, because since we have just 60 elements and we're supposed to perform n number of iterations, sorry about that once again, n number of iterations, sort of really complex process, because if we had n was a real big number, let's say n was 100,000, right? I mean, let's say if we assume n was 100,000, so this would have been a real unrealistic process where actually iterate the whole thing over so many number of elements, right? So that's why from a scalability perspective, this might not be a very effective solution. I think people who've actually come from computer science background and have had knowledge of data structure would really be effectively knowing that this kind of operation isn't really going to solve purpose, and there might be some ways to optimize the solution. Given again the audience of the blogs are people who've not had so much of experience with this, so I'm going to be giving a detailed explanation on what we call as binary search in our data structures, which is so that the concept is really clear and what am I trying to focus when I say scalability over systems and over a large number of users and data streaming. I'll make things more clear. So I'm going to cover that in the next tutorial. I hope what I explained until here really made sense, and now we could actually connect how increasing the number of elements really sort of adds the complexity to the problem and how scalability can then be a big issue. So I hope you guys will stick around for the next tutorial, and I look forward for all possible feedbacks.